Hi everyone, it's 21 News Chief Meteorologist Eric Wilhelm, and this is my annual winter forecast covering mostly the months we consider to be meteorological winter. That would be December, January, and February. Now the snow forecast is pretty much first flake to last flake, and some years like last year we didn't see our last flakes until well into April. But the temperature forecast in particular, we're going to focus on December, January, and February. A meteorological winter, hard to believe, just a few weeks away. Before we get to the forecast, I did want to review some of the recent winters. Temperature-wise, we've had 3 consecutive warmer than average winters after back-to-back harsh winters in 2013 into 14 and 14 into 15. Ever since those back-to-back pretty tough winters, we've had fairly benign winters temperature-wise. Last year ended up being just a smidge warmer than average because of the very warm stretch we had in February. December and January were actually pretty cold last year compared to average. As far as snow goes, we've had a couple of pretty snowy winters in a row after a relatively snow-free 2015 into 2016. And notice that 5 of our last 7 winters have been snowier than average, and we had a long stretch of snowier than average winters from 2006 through the winter of 2010-2011 as well. Actually, that winter of 2010-2011, our snowiest winter on record. A lot of people, kind of remember, oh, the 70s, those were the days. Why can't we have winters like that anymore? And true enough, we did have a couple of really cold winters in 1976 into 77, 77 into 78. But when we talk about snow, we're actually in the boom times in terms of snow for our area. This current decade has been snowier than each of the last several decades, including the 1970s. So this may surprise you a little bit. The least snowy decade since the 70s was back in the 1990s. We did not have a lot of snowy winters back in the 90s. All right, most recently, last winter looked like this. Temperature-wise, it was a degree warmer than average, again, thanks to the very warm weather we had in February, but December, January, and March were all cold. The snow at the Youngstown Warren Airport, which, as you probably know, is in Vienna in Trumbull County. That's where we get our official measurements, our official observations, and the official number for our area last winter was 81 inches of snow. Now, of course, no one lives at the airport. Your mileage varies on snowfall totals every winter. Typically, of course, we see much higher totals once you get into northern Trumbull and parts of northern Mercer County because of lake effect, which is more prominent in those regions, and amounts typically get lower as you get off to the south. Our average annual snowfall in a lot of Columbiana County, for example, is 35 to 45 inches. So it just depends on where you live. But at the airport last winter, we had 81, which was about 20 inches, about 19 inches more than average. So the highlights last winter, it was the 3rd warmest February on record. And in 2017, we had the warmest February on record. So we've had back-to-back really warm Februaries. But the winter got off to a fast start. It was a pretty cold December. We had a fair amount of snow. And then right around New Year's, it got brutally cold. If you remember, if you were out celebrating New Year's Eve into New Year's Day, it was really cold. I think we struggled to get out of the single digits on New Year's Day. So 2018 started very, very cold. But after that really warm stretch in February, we paid the price for the 2nd consecutive year in March. March was colder than February. We basically flip-flopped March and February. We had February and March. We had March and February. So that's the way it went last winter. All right, how do we make these forecasts? I'll get my head out of the way again. This is different than your kind of day-to-day typical 7-day forecast that I show you every day on air and online. Kind of the primary ingredient when the time of the year comes around to make seasonal forecasts, it's basically looking at the past and looking at years in the relatively recent past, going back about 100 years, that had similar conditions in both the atmosphere and in the oceans. We look at a lot of ocean water temperatures when we make these forecasts, and I'll explain why a little more in just a second. We also look at computer models, kind of like we do when we are putting together kind of your typical 7-day forecast. And part of this is a little bit of an art. There's definitely an experience factor that goes into this. I've been making these seasonal forecasts for several years now, and you learn from your mistakes, hopefully. And so your experience and your kind of gut feeling based on what you're seeing, it plays a little bit of a role as well. But this is largely a science-based forecast. This is not throwing darts at a dartboard. This isn't guessing or anything like that. This is not like the Farmer's Almanac, which is put out in August and claims to know that it's going to snow the week of February 21st through the 26th. This isn't that kind of thing. This is hard science here. This takes a long time to put together. And we're going to talk about some of the key factors going into this winter's forecast. Some of this is going to get pretty sciencey and pretty geeky, but hey, you're watching this video, so you must be into this kind of stuff, or chances are you're a little more into science and geeky stuff than those who just want the bottom line. So these are some of the big factors this year. We're heading into an El Nino winter, but not just any old El Nino. It's called a Modoki El Nino, and I'll talk about that more in just a second. Also, keeping an eye on water temperatures in the northern Pacific Ocean up close to Alaska. That can have an influence on jet stream patterns in the winter. Something called the QBO is trending positive or westerly. That's a ribbon of air up near the edge of outer space. Again, I'm going to go into more details on that. We'll also look at the sun when we make these winter forecasts and how many sunspots are on the sun. And again, I'll explain a little more in a second. And we look at a few other things as well, and we'll get into details on all those factors in this video. Let's first talk about what arguably is the most important factor, and that is, hey, we're heading into an El Nino. And a reminder, El Nino is the warming of the waters in the equatorial Pacific Ocean. But the location of these warm waters is very important. In a typical El Nino, the warmest waters compared to average are kind of banked up against South America like this. But this year it's not going to be like that. Every now and then we have a different flavor of El Nino called a Modoki El Nino, named after someone named Modoki, who studied this last century. This is when the warmest waters compared to average are based more in the central Pacific, and actually it could be a little bit cooler than average up against South America. In this flavor of El Nino, the impacts for winter weather across North America tend to be quite a bit different than a regular El Nino. When we have a regular El Nino, and especially if it's a strong regular El Nino, that's a pretty good signal for a warmer than average winter in the eastern U.S. But this flavor of El Nino is not like that, and you're going to see why when I give you the forecast in just a second. Let me back this up. This is a look at some computer models for the El Nino forecast this winter. We're expecting the medium, or the kind of the average, I should say, or the mean of all these models is right through here. What does this mean? We're expecting water temperatures in that zone, that key zone in the Pacific, to be maybe a degree Celsius warmer than average. That's kind of on the border between a weak El Nino and a moderate El Nino. The strength of an El Nino is important. The stronger it is, the more confidence we have that it will impact weather patterns. The weaker it is, then things get a little bit trickier when it comes to winter weather patterns across North America. Again, we're expecting weak to moderate this year. The other thing we're keeping an eye on in the Pacific, here's our El Nino region right through here. The other region we keep an eye on is the northern Pacific, up near the west coast of Canada and south of Alaska. Why do we do this? Well, the atmosphere and the oceans are joined at the hip. They're kissing cousins. The oceans, the configuration of water temperatures in the oceans can have an impact on what the jet stream does. What the jet stream does has a big impact on the flavor of winter that occurs in North America and a lot of other places as well. When you see this blob of warm water up here, a lot of times what happens is that provokes a response in the atmosphere that creates kind of a ridge of high pressure right here. And just like waves on an ocean, for every crest, there's a downstream trough or a dip. So when you have a big ridge that wants to sit right here, downstream of that, typically you have a trough. And an atmospheric trough tends to promote stormy weather. It tends to promote colder weather. The colder air that's bottled up here can glide down into the base of this trough like this. It's kind of like a roller coaster. Here's the crest of the roller coaster, and then it's got to come down. So all the cold air that's up here, it can't go down here, so it has to go this way. So when we see this, that's a signal that we could have a fairly dominant ridge of high pressure across western North America into the Gulf of Alaska, and if that occurs, then odds tilt in the favor of pretty cold weather across the eastern U.S. All right, that QBO thing I mentioned, this is called the quasi-biennial oscillation. What is this? Well, it's a river of air way up in the atmosphere, almost on the edge of outer space. Well, what do we care about that for? Well, studies have shown that this can have an impact on jet stream patterns, on the polar vortex, that kind of circular vortex that usually is parked up over the North Pole. But if that polar vortex dislodges and wanders around on either side of the globe, it can have big impacts in the winter. Sometimes it jogs over to Asia, sometimes it jogs down into North America, and when the polar vortex comes down into North America, you know what that means. It usually turns pretty cold. Well, studies have shown that this QBO thing, when it is in the easterly phase, it tends to promote colder weather in the eastern U.S. When it's in the westerly phase, the chances increase for mild weather in the eastern U.S. Well, we're heading into the westerly phase this winter. We were strongly in the easterly phase. Now we're heading into the westerly phase, which you would think means, oh, so that's a signal for warm weather in the east. But not so fast. When we're in a transitional period like we're in right now, we're going from easterly to westerly. When we're in that transitional phase, studies have shown that that sometimes provokes an atmospheric response that dislodges the polar vortex off the pole, and maybe it'll go to Asia, maybe it'll come to North America, but it increases the chances of that polar vortex wandering around a little bit. And so that's kind of interest as we go into the winter weather season. We're in that transitional phase, so that could have some implications. Remains to be seen. But we're heading out of a strongly easterly phase to a weak westerly phase. All right, we look at the sun. Why is that? All right, so the sun is heading into what we call a solar minimum right now. In other words, there's hardly any sunspots on the sun. Now, this picture is from 2009, but it's fairly representative of the sun's condition right now. Roughly every 10 years, we head into one of these solar minimums. We had one back in 2009. We're heading into one right now. Well, so what? Well, the reason we look at this is when a solar minimum coincides with some atmospheric conditions in the winter, studies have shown that that increases the chance for some blocking patterns across the northern Atlantic. What I mean by a blocking pattern, that means a ridge of high pressure that kind of parks over Greenland in the northern Atlantic. When there's a ridge parked right there, guess what? Cold air masses can't penetrate that thing, so they've got to come south. And so you get colder air masses that tend to want to sit over eastern Canada and the eastern U.S. when you have blocking, like a roadblock, over the northern Atlantic and up towards Greenland. A quiet sun has been shown to increase the odds of more blocky patterns across eastern North America. Another thing we look at this time of the year, the increase in snow cover in parts of Europe and Asia, especially in Siberia. Another one of those things like, why in the world would we look at this? Well, studies have shown, these are relatively recent studies, but there's a pretty good sample size here. Studies have shown that when the snow cover increases at a pretty rapid pace, especially in October in this part of the globe, that increases the odds of that blocking type pattern that I just spoke about occurring again over Greenland, northern Atlantic. And so the increase in snow cover in this region was not very notable in the first half of October, but very late in October, it really started to increase fast. So I think this probably does tilt the odds in favor of a blocky pattern this winter across the northern Atlantic. This works particularly well when the El Nino or La Nina signal is not strong. When there's a strong El Nino or a strong La Nina, that tends to overwhelm some of these other factors like the snow cover thing. But when El Nino or La Nina, the opposite of El Nino, is fairly weak, then this can have a bigger impact. It's something I'll be keeping a close eye on as we go into the winter. So I talked about, one of the key ingredients when making a winter forecast is looking back at the past. What I tried to do was find the best matches to this year. Years that had a weak to moderate Modoki El Nino, not just a regular El Nino, but a Modoki El Nino, that had that blob of warm water in the northern Pacific, that were hopefully close to a solar minimum. Things like that. I tried to find the best matches for those conditions. Here's the list I came up with. My two best analog years were the winter of 1987-88 and the winter of 77-78. 87-88 was not particularly noteworthy. It was a little bit colder than average. It was somewhat snowier than average as well. 77-78, a lot of people remember that winter. I happened to be born that winter. Famous for the blizzard of January in 78. It was a brutal winter. 7 degrees colder than average in December, January, February. The snow was above average. It wasn't through the roof, but it was above average. At times during that winter, it just was so cold that most of the moisture was to the south and it didn't snow that much. But we had a couple of big storms that winter. kind of on my secondary tier of years here, we have some winters that weren't that cold. In fact, some of these winters were a little warmer than average, including 94, 95, 86, 87, 91, 92. We had a pretty severe winter on this list in 2002, 2003, and this was a somewhat cold winter in 2009, 2010. On the snow front, 94, 95 was like a snow-free winter. It hardly snowed. I mean, that's like almost half of our typical snow. 91, 92 was also a little below average, but these other years were all snowier than average. You'll notice that 5 of the 7 years shown here are snowier than average. 4 of the 7 years are colder than average, leading you to believe that odds would be tilted in the direction of a little snowier than average and colder than average as well, based on those analog years. Here's what the national map looks like when we throw all those years together and come up with kind of an average, with the best 2 analog years weighted more heavily than the other years. It's a pretty cold looking map across the northern tier of states, down into the southeast, all the way to the Gulf Coast, the warmer than average conditions out here across the west coast. That's what the national map looks like in terms of temperatures, in terms of precipitation. There's a signal for drier than average conditions in the northwest and parts of the Midwest. A wetter than average pattern across the southern tier of states. You can kind of see where the storm track likes to set up. Right down through here, and then storms come up the east coast like this. This is the kind of pattern that leads to a lot of nor'easters, a lot of east coast storms in this kind of a pattern. So that's kind of what we get when we look at all those years, and you'll notice the precipitation anomaly or difference from average. In our region, there's not much of a strong signal. It doesn't look wet. It doesn't look that dry either. Not as wet as to our east, not as dry as to our west when we look at those analog years. All right, so let's get to the forecast. Based on those analogs, based on some computer modeling, and based on some experience and intuition as well, here's what I've come up with. This is for the winter, December, January, February. I'm calling for a colder than average winter here locally, perhaps even much below average depending on how things go in the second half of winter. I'll talk about that more in a minute. But that's kind of the overall look for the winter, December, January, February, likely to be a colder than average winter for the first time in a few years. But unlike last year, I don't think winter gets off to a particularly rocking start. There's even a chance that December ends up warmer than average. It looks pretty mild in early December. That may be balanced out by some colder weather later in the month, and I have right now kind of an average December. But there's a chance some of this warmer weather just sticks around too long and ends up being a warmer than average December. There's not much information out there to suggest that December will be noteworthy for cold. So that's the way December looks right now. I put my confidence on this at medium to medium high. The month I had the most trouble with in this forecast was January. We're likely to transition, as we flip the calendar into 2019, we're likely to transition into a colder pattern. The question is when? Does it wait until February, or does it occur sometime in January? There's conflicting signals on this. Right now, I have us a little below average for January. Little caveat here. Some of the longer range computer modeling is quite a bit warmer than this map, suggesting that the kind of mildish December pattern may continue into January. The analogs, if you just went by the analog years alone, odds would tilt in favor of a pretty cold January. So this is something I have a little less confidence in. I would put my January forecast confidence level at kind of a medium to medium low right now, a little lower than my December confidence. My February confidence is quite a bit higher. February could be a pretty rockin' month for both snow and cold, unless it gets too cold. If it gets too cold, like in that winter of 77, 78, it got so cold, especially during the second half of winter, that the air was so dry and cold that all the storms were down in here. And there's a chance that happens this February, but I'm very confident. I put my confidence in the February temperature forecast at medium to medium high, that it's going to be a colder than average month, and there's a chance it ends up being severely cold. One thing I'm pretty confident of, again, is that February is going to be a lot different than the last 2 years. We've had 2 remarkably warm Februaries in a row, and not only will this year be a more typical February, it's likely to be a pretty memorable February temperature-wise. It remains to be seen how much snow we see in February, but if it gets too cold again, we'd probably miss out on some big snows. We might get nickeled and dimed here and there, but we'd miss out on a lot of big snows if it gets too cold in February. That sometimes happens. All right, snowfall forecast for our local area. All right, as usual, much more snow in the areas that are prone to get lake effect. That would include, of course, parts of Trumbull and Mercer counties. Typically, snowfall totals in a place such as Greenville and Kinsman are way higher than a place such as Lisbon, Salineville, East Liverpool, East Palestine, Calcutta, Wellsville. Those kind of places typically see about half the amount of snow that we see up in northern Trumbull and northern Mercer. Here's my forecast for this year. All these numbers are near to somewhat above average. Again, at the airport in Vienna, right about here, we average about 62. I would venture to guess at the Youngstown Warren Airport this year we'll see 70 to 75 inches. A little less than last year, a little more than average. Not a crazy amount of snow. The numbers might be a little bit higher kind of in this zone through here, the eastern end of our viewing area and closer to Pittsburgh. Why is that? I suspect that, that active storm track I showed you on the national map would lead to a lot of East Coast storms, and if those storms aren't offshore but more hugging the coast or a little inland from the coast, western PA could do pretty well with snow from big East Coast storms this year. So your snowfall totals might trend a little higher in places such as Newcastle, Elwood City, heading down into Beaver County and closer to Pittsburgh, and even parts of southeastern Mercer County, a place like Grove City. Might do pretty well if we get a lot of East Coast storms. But overall, again, no matter where you are on this map, I'm expecting maybe a little less snow than last year, but still a little bit more than average. So, summing things up, I'm expecting a backloaded winter. Kind of a slow start, but it could really flip in a hurry once we flip into the new year, and February could be pretty harsh. That's a possibility. Expecting overall precipitation to maybe even be a little below average, but snowfall maybe a little above average. And so I wouldn't expect a lot of rainstorms or high precipitation non-snow events, especially in January and February. Overall forecast confidence, I would put it at a medium, and I'm going to have an update on this forecast coming up. I believe that's the first Monday in December, December 3rd. So here's how my confidence breaks down overall. Pretty confident that, yes, we're heading into a weak to moderate El Nino, the QBO phase I talked about, medium confidence in terms of temperatures, snow totals, and impacts as well. Expect higher heating bills this winter as a result of those colder temperatures, especially later on in the winter. Expect salt usage to be maybe on par with last year or a little less than last year. A lot of teachers like watching this video and are really interested in what will happen during the winter as far as school adjustments go. I would expect our school adjustment numbers to be a little above average this winter, particularly if we get into that harsh cold pattern during the second half of winter, especially into February. We may have a lot of delays for cold, maybe even cancellations for cold if it gets cold enough, especially later in the winter. Again, the snow forecast, I don't expect this to be a historically snowy winter. I would expect it to be a little bit above average. All right, that is the super detailed version of our winter forecast. We'll check back in a few months and see how I did. I like grading this forecast at the end of the winter. I did it this year, and I'll do it again in March of 2019. If the forecast busts, you'll hear it from me first. I have no problem admitting when I'm wrong, and if the forecast is on the money, then I'll tell you about that as well. Thanks for sticking with me on this long video. You can check out the short version of this video on WFMJ.com. If you're more of a reader at this point, if you're still watching this video, chances are you're more of a video watcher than a reader. But if you want more written blog version of this winter forecast on Eric, WFMJ.com.